Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us today to stay curious. Got a beautiful background shot here on Christmas week of the moon poking through the clouds over the Indian River and the Max Brewer Bridge. Familiar sight to me, and the bridge is, and the river that is, to me and my co producer, Marty Winkle. Good afternoon, Marty. Great to see you today. How are you, sir?
I'm doing good, Mark. How are you?
I was out and saw one of our favorite astronauts, Jose Hernandez, today, and we're going to plug his movie at the end, A Million Miles Away. We're plugging it now on Amazon Prime. Brought tears to my eyes, really, a good sentimental story about Jose, a migrant worker who wouldn't say no, and on his 12th try, become an astronaut. And great. All the astronauts had awesome things to say about Jose, don't they, Marty? He and his wife were great friends of the Stotts, and uh, Kay Heyer had high words to say about him. And you saw him the other day. So we'll say a few words about him at the end of the program here in the way of that he wants to help our museum. So stay curious about how Jose Hernandez, astronaut and biopic subject, a million
Ast-
miles away, said.
Astronaut and if I can't pronounce it, entrepreneur.
Astronaut entrepreneur. He's got a grape farm. And I was tickled that you corrected yourself, Marty, because it was a vineyard, but that's a grape farm. So instead of a vineyard, hey, it's hard to pull the words out of the air sometimes when you got all this gray hair. Speaking of which, it's the Christmas season, and we all hope, speaking of words in the air, it's the Christmas season. We wish everybody winter wishes. Today, we're going to talk about happy winter and happy summer to our good friend Cliff Watson down under. All right. Um, but it's the holidays, Christmas, Hanukkah. Uh, you've got Kwanzaa and Festivus for the rest of us if you're a Seinfeld sitcom fan. And I want to thank Marty for this beautiful shirt that he bought me. Thank you. Marty's always given, if you want good Christmas gifts, you become a friend with Marty Winkle. Like you gave me this a couple years ago. Caution, might start talking about astronomy randomly there. So appreciate this and a cool looking shirt, Marty. Thank you very much. And we'll wear that around town, and everybody knows I'm a space geek all the way. We're going to talk about the solstice. You're going to understand why that we're having these changes of seasons. I'm going to get up here and grab the globe over here that I forgot the globe. It's all about in the tilt of the Earth's axis of that globe that you've seen on every teacher's desk if you were a 60s baby boomer like me. And Of course, we have a green screen, and the countries and continents that are green don't show up so much there, but it's all in that 24.5 degree tilt. And we're going to make sure you understand that that's the reason for the season. And so, hope we all have a good holiday. Let's get into that right now. Where we got the solstice is the time of year when Marty, would you hand me the map on my desk over there, sir? Forgot to bring that over here. We were back there eating some of the Christmas food left over from the astronomy club meeting in our museum. Can't say anything better than this. The December solstice is the time when the sun reaches the point furthest south of the celestial equator, making the start of winter in the northern hemisphere and the start of summer in the southern hemisphere. And it all has to do with the direct or indirect rays of light. I've equated this many times that you don't go out from 8 o'clock to 11 o'clock to get a suntan because the rays of the sun are really slanted and they're not hot. You get a suntan from 11 o'clock to 3 o'clock when the sun's overhead and those rays are beating down directly, and it makes a big difference in the energy that's being emitted from our favorite star, the sun. So here's the way it looks every 6 months, where the moon, this earth is in a completely opposite side of the sun, whether it be June to December or July to November, whatever it is, the opposite, the tilt is either going to be away On the right-hand side, the North Pole is tilted away from the sun. That is December solstice going on. Where the Tropic of Cancer, that's why we have the Tropic of Cancer and the Tropic of Capricorn. Those are those two bands on either side of the equator where the sun literally is standing right now above the Tropic of Capricorn, above the southern hemisphere. 6 months from now in June, the sun will be directly overhead at the Tropic of Cancer, and the southern hemisphere will be experiencing winter. This winter solstice blessing is a nice way to think about how the ancient peoples of antiquity thought about it as a rebirth. Now is the time to honor the rebirth of the sun, to remember the light in the darkest part of the season with the hope of good things to come and the promise of a renewed life. Because today is the shortest day of the year, all right? The least amount of sunlight is going to be on the northern hemisphere. And from now on, golfers, tennis players, gardeners, every day is more light is going to be advancing into the evening. Again, to emphasize the low angle of the incoming sun is at the poles. That's why it's colder up there. The sunlight strikes most directly, of course, in the center of our globe. And when we're leaning into it, like it shows here, we would be experiencing summertime on the northern hemisphere and winter in the southern, because the low angle of sunlight coming in the south. All right. This also serves to heat up our atmosphere differently, and that's what causes a lot of the storm systems and so forth, and may even have a bearing on the airstream. Yep, I'm going backwards there. So remember, the solstices are when we're on either side of the sun and tilted furthest away or right into the sun. The equinoxes, equal day and equal night in the spring and summer, the vernal equinox and the autumnal equinox, and of course the autumn, that experiences 12 hours of day and night on there. As you can see, though we're tilted, the tilt and the angle is such that you don't have the complete loss of sunlight because of the orientation of the earth. Time of sunlight, not sunlight in general, but the length of sunlight. So you have winter time, and of course one of the most famous stories of timekeeping is Stonehenge there in England, where this configuration shown here in the winter time was and is thought to be an astronomical calculator and calendar. In between the stones, the winter solstice rises exactly today. It's at 10:21 p.m. is the exact moment of it. So this would have already gone on this morning in England. And this is just one of hundreds, if not thousands, of type of timekeeping tools that ancients used throughout history to understand why these things are moving. In Astronomy Club, we had yesterday night, somebody mentioned that, very few people even understand why the sun is moving across the sky. They think the sun's moving. No, it's the earth moving in the eastern direction, and everything moves to the west. So to take our minds back in time, when the stars echoed more meaning than today. Today, hardly anybody looks up at the stars. We're going to talk about that at the end of Stay Curious. What's up on Christmas Day that you can see? So these ancient monoliths are important to understanding how the history of science evolved, as well as we understand more about our ancients. We understand more that they're a lot more intelligent than we thought. In fact, they're just as intelligent as human beings today. The brain capacity and all that isn't that much different. And there's a lot of things that, of course, didn't survive the thousands of years. Think about that thumb drive in your desk with your family pictures on it. Is that going to survive 100 years from now, 200 years from now? Is it just going to go poof, the data on that? Is a solar storm going to wipe it out? I don't know. There's many ways that we lose history of data. And while it is some winter time in, of course, England, in Australia, it is summertime. I wanted to get the exact beach here. This is Bondi Beach, famous beach on the eastern shores of Australia. And Cliff Watson, maybe you've been to Bondi Beach. I think it's below Pomona where you live, but their beaches will be full first day of summer in the Australia, South Africa, South America, and all the ships at sea in the Pacific and all those Tahitian islands. That's because of this tilt of the Earth. All right, the winter solstice, December 21st. Now, here is where we get the interesting amount of daylight that we have. And this, again, 12 hours of equal darkness at the equator. Tropic of Cancer would have 10 and a half hours of darkness. Arctic Circle, 24 hours of darkness. This is what it would look like, the sun rising over your home. Got some solar panels on that home. That's why you want your solar panels in the south. You will never see the sun next to the Big Dipper in the north. You'll never see any planets north of overhead. Or the moon will you ever see in the Big Dipper or the Little Dipper or Cassiopeia, those circumpolar stars, because of the tilt of the Earth. Keeps them in a sky that is south of overhead. And as the sun's path gets higher, it's more longer in the sky, days are longer, and things get heated up. So what does that mean technically? Well, today, sunset's going to be about 4:47. We'll be driving home in the darkness. Sunrise is at 7:12 a.m. The summer solstice was at 4:47 p.m. Actually, that's last year's. I didn't update that. It's at 10 p.m. Sunrise at 7:12. Sunset at 5:31. That's 10 hours and 15 minutes of daylight today. 6 months from now, we're going to have 14 hours of daylight as the sun rises at 6:26 and sets at 8:24 p.m., not adjusted for daylight savings time. Actually, it is adjusted for daylight savings time, I think, or it'd be 5:26 a.m. 14 hours of daylight 6 months from now, barely, little over 10 hours. That's 4 hours difference, my boy, and that is a big deal to everybody that enjoys outdoor activities. You know who loves just having 10 hours of daylight and 23 hours and 45 minutes of darkness? Stargazers, okay? Because we can throw our telescopes out at 7 o'clock and take them in at 10 o'clock and get a plenty night's sleep instead of having to wait till 10 o'clock at night to see the Milky Way in the summertime. So different strokes for different folks, but there you go. 10 hours of sunlight today, 14 hours, 6 months from now. There's that beautiful picture of the midnight sun. All right, just barely up there. This is somewhere in Finland. All right, let me go back to the forward again. Looking at another Druid remains and the beautiful sunset somewhere in England. And with that, we're going to kind of segue from the winter solstice. Hope you all enjoy the longest night of the year today. And I'll be out stargazing somewhat because the moon's going to be interfering. And why does the moon interfere? In this photograph I took of a full moon coming up over Cape Canaveral Beach in the Atlantic Ocean, because we're going to have full moon is Wednesday, day after Christmas, all right? The moon tomorrow night is going to be near the planet Jupiter. And Jupiter is the brightest star in the sky. It's not a star, of course. It's brighter than any of the stars. Saturn is up overhead also, but you're going to see more brilliant Jupiter. And then in January, come to the museum and we'll show you Saturn through a telescope. It's easy to see with the naked eye. There's that moonscape I took. You never know what the moon's going to play in the sky. So just don't discount it as a full moon. Go out and see if you can get, maybe there might be a ring around the moon. What's that ring caused by? That ring around the moon would be caused by ice crystals up in the atmosphere. And they're certain sizes. They're actually rectangular and hexagonal, and they reflect light that throws 22 degrees around the moon. You might see that. And count the number of stars inside that ring, because some cultures used to say that's how many days till it rains or snows or a new king is going to be born. One of the places I promote that is free and is skymaps.com. You can, they encourage educators to use anything on this page, including this nice handy map here that I've printed out, and you can print out. This is the evening sky for December. Now that band in the middle there, the bluish band, that is the Milky Way. And this map is sort of like for the middle of the month, because the Milky Way still is overhead. The sky, it shows how the night sky looks in early December at 8 o'clock or late December at 7 p.m. And of course, by 9 or 10 o'clock, the Milky Way has set. But what you see rising in the horizon in the left-hand side is the Orion the Hunter, okay? And this is the front page of skymaps.com. And then you scroll down and you can download their map. And there's Orion on the left-hand side. Up above me is Capricorn, if you're born in January. And then Piscis Australis is there. And looking south, that's the southern fish. I wasn't swearing. Piscis Australis, okay? That's the southern fish. Fomalhaut is really the brightest star in this whole area when you look to the south. And that's Miami for you folks in Florida. And you folks everywhere else, look towards Florida. And that's south. And this star is very distinct by itself. And up by it, up here, is the planet Saturn right there. So you're going to see two bright stars looking south, and there's not much in that area on Christmas night in the next month or so. And that is called, because there's hardly any bright stars there, Fomalhaut is called the lonely one. The lonely star is what that meant in Greek. And we'll feature Fomalhaut because it's quite an extraordinary star. We're going to talk about Orion the Hunter, of course, here as we look at the sky on Christmas night, 2023. I've connected the dots of Taurus the Bull there. What it doesn't show, there's the Pleiades. The Pleiades star cluster and the moon team up on Christmas Eve. You go out Christmas Eve, you're going to see the moon. You're going to see a tiny little, it looks like a tiny little dipper, but it's the 6 stars that you see naked eye of the Pleiades star cluster. So you got some interesting constellations. Orion in the middle, Gemini the twins to the left or north of Orion. Above Orion is Taurus the bull and its red star. You've got Lepus the hare is at the feet of Orion. And Monoceros the unicorn is rising. And then the brightest star in the sky, that's a star, Sirius, is rising, and Canis Major, the big dog, and the little dogs right beside him. So we got a lot of activity going on with some of the brightest stars of the season. And here I put on this program, Stellarium. Think aquarium, but the sky, a Stellarium, a free download, a planetarium in your pocket, or in because it's an app, or on your computer at home, and you can put your date in there and see what the stars look like on your date of birth or any time in history. So this is December 25th, 2023. There's what the ancients thought the artwork of the sky looked like, with Orion the hunter. There you see Monoceros, the horse, the unicorn, 2 dogs following it, the brothers, Gemini on the left. This big snake is Cetus, the whale, and the bull Orion, or the bull Taurus. And here's just to show you, you're going to see a whole bunch of bright stars when you look out at the night sky. And Ble Juice and Rigel there in Orion are 2 of the best. So let's look at Orion, because you can't miss Orion. It's like the Big Dipper. Once you see it, you know where it's at. And at 9 o'clock at night, it's going to be right up pretty high above the eastern horizon when you go outside to catch a breath of fresh air on Christmas night. Let me get a sip of rocket fuel here. Ah, that's some good stuff in there, Marty. Well, we've got the main stars of Orion are all named by ancients. The left hand is Betelgeuse, and look where it's at. Yes, Betelgeuse translates in Arabic to armpit of the giant. See, it's right in his armpit, Marty. Bellatrix is also an armpit star. There's stars that he's holding either a shield or a dead animal. The bottom two stars of his knee, Rigel and Saf, are interesting stars, but I love the belt stars, Mintaka, Alnilam, and Alnitak. All right. And dangling off the belt of three stars is the Sword of Orion. And in the middle of the Sword of Orion is a naked eye birthplace of stars called Orion Nebula. We'll see here in a minute. Well, here I threw a little star filter on Orion, a photo that I like, I've taken a few years ago to emphasize the brightest stars. And right there in the middle, dangling down from the three stars of the belt, is a blob, and that's the Orion Nebula, a nursery of hundreds of thousands of stars, and it covers an area from our sun to halfway to the nearest star, or further than that, 100,000 light years at least. The nearest star is 4 light years away. All right, where am I going? I'm going. This, if you could see in infrared, in hydrogen alpha, all right, this is what Orion looks like. And this is a wonderful astrophotographer up in Tennessee. Took this. I'm trying to, I forget his name off the top of my head, embarrassed about that, but Matt Harbison. This is basically the same image, Marty. There's my star shot. There's Matt's. You see the three stars of the belt. You see Betelgeuse up at the top. Okay. What's going on here? This is the invisible universe, folks. That is a gaseous cloud that is embedded behind the stars of Orion. All right. And honest to God, we can't see it, but if you had a hydrogen alpha filter on your eyes, you could see it like that. And this is a photograph that Matt Harbison stitched together of thousands of images with thousands of hours of time doing this. Quite a feat for you all. And of course, buried there in the middle in the star below the 3-star belt is the Orion Nebula, and the Horsehead Nebula is in there below Alnitak, the last star on the bottom. Gorgeous, isn't it? Well, these are these stars, and all stars that you look out of the sky is a time machine. They are different distances from us. It is just a happenstance of juxtaposition that these stars look like the dot-to-dot outline of a man or a woman. Betelgeuse is 3,300 light years away. In other words, the light that left that star left it in 1723. 1713 to be exact. Alnitak and Alnilam are 1,200 light years away. They're 1,000 miles further distance than Betelgeuse. Yet they're pretty bright. If they were as close as Betelgeuse is to us, they'd be brighter than Betelgeuse. Mintaka, the other belt star at the top, is another 1,000 light years away. What's a light year? Light year is basically 8 trillion miles. Light goes at 186,000 miles a second. That's 7 times around the Earth's diameter. In 1 second, if you put a railroad track on the equator, you were a ray of light, you could never cross it. I mean, you could never cross it if you put a ray of light around it. It would circle the globe 7 times in 1 second. All right. That's fast. That's a big distance. So we gauge big distances in a time frame of light years. The sun is 8 light minutes away. Even at 186,000 miles a second, light takes 8.5 minutes to go 93 million miles. Now you can kind of relate. The moon 250,000 miles away, it's 1 light second away. I said 186,000 miles a second. It's a little over a second away. Saf down there at the bottom, 1,300 light years away. Rigel is 910 light years away. The Great Nebula of Orion is 1,300 light years away. All right. Oh, and that is embedded. So Saf and the Great Nebula of Orion are embedded in this incredible hydrogen cloud that you can't see but's there. And then Bellatrix, the other armpit of the giants, 310 light years away. So the theory is that Betelgeuse, Bellatrix may have been born out of a cloud together and ejected out of this massive hydrogen alpha cloud. But isn't it interesting that these stars have nothing to do with each other except the line of sight, like rows of telephone poles or the like. This one star Betelgeuse is very interesting. The upper left-hand armpit of there you see it's a big star. The size of the Earth's orbit is shown inside the size of the star in this Hubble telescope image. In other words, Earth's orbit can fit inside of this gigantic star. And the size of Jupiter's orbit, yeah, it would almost, if we put it in the middle of our solar system, Betelgeuse would swallow up Mercury, Venus, Earth, Mars, and Jupiter. Incredibly huge star. The Webb telescope is going to look at it. We think it's wobbly, because it's an old star that has burped up all of its energy. The hydrogen's turned into helium. Helium's lighter, expanding this star out. And any day it could explode. Marty, every time we go out and look at Betelgeuse, we amateur astronomers are hoping that we're seeing it brighter, and blow up. Well, a year ago, it got fainter and fainter. It's noticeably fainter. I noticed noticeably after maybe 2 or 3 days of clouds, and I saw it, and I'm going, wait, it looks a little dimmer. What happened is theorizing like a cloud of debris off of this aging star blocked some of its light from Earth, and it got dimmer, and then it straightened up. So this is an active star. You know those big balloons that kids play with the big, I love bubble balloons, but the one with the wand and it's a big old wobbly thing, that's what this star will look like when we get a good close-up of it with the Webb telescope. They're working on that right now. They've probably taken the image. They're just enhancing it to unleash it to the world. And here is the closest images of that star, Betelgeuse. We notice that it's got bright areas, dark areas. Like our sun has sunspots, okay? Maybe it has big star spots on them. And a week ago, an asteroid passed in front of Betelgeuse, and it was a big deal down in the Miami area where you could see it because we were going to get the size of this asteroid that was about 10 miles across, pretty big asteroid, in fact. And they thought that Betelgeuse would wink out for maybe up to 10 seconds, and it got a little dimmer, only for a few seconds, not what they predicted. But that's why we watch things, to predict them. But this is the actual shape and surface of a star as seen through the latest telescopes. And again, there is our hunter. You can see his arm up there with a sword and his shield or his animal in front of him, all kinds of interpretations. Universally around the world, cultures have called this a hunter or a man. There is the big nebula of Matt Harbison's picture of the Great Nebula of Orion there. Gorgeous, beautiful shot. That is one of the first things that everybody wants to photograph as a photographer. And certainly I've taken my share of photos of it. What's interesting is the balance of the birthplace of stars inside. There's 4 stars inside that are called the trapezium. It looks like a trapezoid, and that's a good test of telescope optics. And it's overexposed here because you got to overexpose to get the delicate balance of all of that gas in there. And this is just a portion we can see with visible light. This is not that infrared that engulfs all of Orion there. So quite a spectacular looking Great Nebula of Orion. You can see it in binoculars even, Marty. So get those sports binoculars out and look at the stars. Look at the moon. The moon is going to be next to Jupiter on next to the Pleiades on Christmas Eve. The moon is next to Jupiter on Friday night, tomorrow night. You'll see the moon and Jupiter together. Then it'll be near the Pleiades on Christmas Eve. Full moon is Wednesday, and then it moves on throughout our sky there. So, well, let's put a button there on the winter solstice. Hope that you all have enjoyed the shortest day, the longest night of the year. Steve J, thank you for watching at Lake County Spaceport there in Illinois. Dave Stange and his granddaughter, hello to you, little girl there. Merry Christmas to y'all. We'll have one final show tomorrow and talk about the Star of Bethlehem. But I do wish all of these friends here are great supporters, and we're going to do ways to reward you next year. We're constantly thinking of how to improve our American Space Museum outreach. Marty, you got a question on our UCX family microphone?
Yeah, Cliff Watson's asking, have you seen Tom Pickett's photo of Beetlejuice? Pickett Bell have a good look, friend of mine.
Oh, no, I haven't, but I will. A friend of yours took a picture of Beetlejuice. I'll look that up, Cliff. And first day of summer to you, buddy. Go get your swim trunks and go out there to that beach I talked about, which was Bondi Beach. And we will see Cliff Watson in 2024 as he's coming to the States for the Great American Eclipse, April 8th. Dave Stange, thank you for all your support. Doug Forrest also in Los Angeles. Mark and Tom Usiak in Lancaster, Pennsylvania. We've been shivering here, guys. It's gotten down to 50s at night. I think it even reached 40s in some of the places, right, Marty?
I think so.
Yeah, boy, we're hit hard here, guys. So hang in there for us, okay? Bill Whiting, hang in there yourself. Merry Christmas to you. We've got summer starts on December
1st.
Oh, in Australia, okay, but not the equinox. Okay, thank you, Cliff. So the Falcon Heavy is going up on the 28th. Thanks for that little note there, Marty. 7 to 11 p.m. I'll be up in Tennessee and watch it on the live broadcast of that. That is the spy plane, the mini shuttle going up. And that, if it goes off at 7, I predict you might get that twilight, maybe some of the jellyfish going on, coming back with those 2 boosters coming back. So I'm going to probably miss a good one. Marty, you have to tell me all about it. So, well, we wanted to give a plug to a friend who's going to be a friend of the museum, but a great guy, astronaut Jose Hernandez. His one space flight on STS-128 was a life changer for him, a dream he had as a young boy in the migrant fields of Los Angeles area. A Million Miles Away is based on his true story. Michael Pena is the actor there. And here's a picture of Jose with me today. See, Jose is handsomer than Pena there, I think. But he's got his mustache, okay? I didn't like that they didn't have a mustache on Jose. But a tearjerker at times. What a family, what a story. He and his wife are still very much together. His kids are all overachievers, Marty, talking to some of the astronauts who know him. Quite a family and quite a tribute. He's got 3 books out. And there he is, Mr. Jose Hernandez. Please watch that movie on Prime. You will not, it'll be a good Christmas present to yourself. All right, so hoorah for holidays there, Marty. And you were going to have a comment.
Yeah, one of Jose's oldest son, I forget his name, and he spoke about this on Astronaut Encounter. He's going to Purdue. I think he's working on his PhD, and he's going to be he's a future astronaut, or at least a wannabe.
Right.
So as far as I know, that might be the first father-son astronaut.
Well, in fact, it would not be, because you have the Garriots, Owen Garriott and his son, that paid for his way to go up on there. Were the first father-son, and I think there's a Russian father-son. But Marty, how about making that a research project for you over our vacation break here, my friend? We're going to do a program on the Star of Bethlehem as not a religious program at all. but is a fact of the most well-known star and thought about in eternity and on all those Christmas cards. What was it? What could it have been? And so it's not a Christian talk, it's an astronomy talk about that. And then we will be gone for a week live, but we'll be posting some uh, reruns of some of our astronaut encounters, some other shows. Marty and I were talking about it, what ones we want. But I also just wanted to say we were going to spread a lot of love to all of you who support Stay Curious, whose names I read off here and others after the beginning of the year. And we really want to thank everybody in a heartfelt way for what you've done in our recap of 2023, which will be the second week of January when we get things going again. Yes, Marty.
Mark, why don't we ask the audience to, if they have a favorite they'd like to see, have them either email you or message us tomorrow.
That's right. If you'd like to see another program or think that other people should see it, mention that to us, whether it be astronaut Mike Baker, Charlie Walker was on here this year, another fabulous astronaut. We had Chris Stott's going to land a hard drive on the moon sometime in February on a launch by Intuitive Machines. I'm looking over here at our sign sheet of things we've had on here. Mr. Jay Honeycutt's helped us a lot lately. So if there's a show you'd like to see reprised, let us know that. My email is marq@americanspacemuseum.org, or contact us on the YouTube comments or on Facebook. You know how to get a hold of me. And I'll bet Dave Stengy's got a show or two he'd like for his granddaughter to see again. So we do appreciate everybody, and you're going to know it after the beginning of the year as executive producer and director of this museum. Karan, Conklin, and I have been in constant contact with some new partners, and you're going to love it as we help each other to have a forum that everybody can spread the cheer about the space age, past and present, as well as the future. So until then, I'm Mark Marquette saying, everybody, slow down in the hustle bustle of these final days before Christmas, all right? Everybody wants to get there too. So be kind. And until next time, I'm Mark Marquette saying, I can't wait to see you tomorrow to bridge the space between us.